Hello guys, let's do something different today for a change. Instead of lead coding, we'll do model training using Google Colab. And for that, let's look at what are the different types of machine learning tasks we may come across in the industrial world. So one is classification, which is what we would mostly focus. Other is regression, and then we have clustering, where you group similar items without label, something like used in customer segmentation. Then we have anomaly detection, where we find rare or unusual patterns, for example credit card fraud detection. And then we have generative modeling, where you generate text image synthesis. So let's focus on the classification today, where we would try to run some object detection models in Python. And two major categories of those models are classical and deep learning. The classical is, in this case today we'll use hair cascade, which is one of the classical ML models. This is the code, and this is on Raspberry Pi, and this is my Raspberry Pi setup. And as you can see, I have a USB camera connected to the Raspberry Pi, and it is capturing images in real time. And as we capture images, it puts a bounding box if inside the image on a object. If it sees there's a face, then it would put a bounding box on that and then say face detected. So let's see if it does. So here is the code, and as you can see, I tried to run the code. Python code is saying a face is detected because a person is actually sitting on sofa in front of the camera. So I hope it was all useful for you guys. And so now let's run two other models. We will actually do training this time rather than just run the models. So that last time what we did was actually inferencing, not training. So this time we would try to train a model to detect the digits in MNIST database. This is a popular database. So let's do that. And so let's head over to Google Colab. And as you can see that Google Colab is, we start with a new notebook. And one thing you see here is, you see in runtime, you have to change the runtime because you want to run your model on a GPU, otherwise it will be very slow. So usually that's what I do. And first thing is, let's try to upload an image that we'll use for testing. So you say insert code cell. We already have a code cell, so let's do that. Okay, so this is a code for you can get it somewhere in Google, I guess, or ChatGPT or something, who knows. And then from google.colab import files, if you run this code, if you say here, basically this arrow says run this code. So now we're going to run this code. So okay, no file selected. So here let's see. So we're gonna do, we go to downloads. So I think, yeah, we go to downloads, and then we go to 4 image dot. So you see CDEF 4 image, right? EF father son 4 image. There you go. So this is an image of a 4, which is a very fuzzy 4. It's not a good 4. I mean, it could probably confuse the model because it has this thing coming out. It looks like it could be model might see. We can see as human beings there is 4, but let's see if the model can recognize that. So we just really load this image. Okay, so now let's run the multi-layer perceptron MLP model, a dense fully connected network. So how are we going to do that? So I have the code here, and we would, as you can see, this is the code for digit detection using MLP models, and this is basically easily available off the internet. Of course I didn't develop it from scratch, but basically what it does is, if you think about it, it's using TensorFlow. So tensorflow STF, and then you use keras, checks for GPUs, how many GPUs are available, load MST database, does it for you, you don't have to download, it downloads it from the internet, which is basically a 28 by 28 pixel images, the of the digits like 1 2 3 4 and all that. So and then here you can see it's basically flattening. So 28 times 28, so basically what it does is instead of x and y, it just puts all of them in a vector like 784 pixels. And there are a lot of other terms which are, I would say, I'm still trying to come to grips with. For example, try to understand what activation is. So neural network, there's a concept of backpropagation, activation, all those things. So take a look at that. But basically, from the programming point of view, you need to understand that you're importing a models class from tensorflow.keras. Then you're creating a model. You're basically calling the sequential object there and passing bunch of stuff. Then you're saying, so you're getting model initialized, and then it's a model.compile. Then you model.fit with your data that you got. Epoch says how many times, how many passes it goes through. So it will go through 5 passes. And then it predicts on some of the, for example, 5 first images here, you can see it actually picks up 5 images from the test data and then does the prediction. And then we have our own code. So here, by the way, we actually loaded here 4 underscore image.png, otherwise you will have problems. So 4 image.png. okay, so now we will run this model. So what I'm going to do is, let's cut and paste this whole code in Google Colab. So cat on this file, and then we go to multi-layer perceptron. Okay, TF. Okay, so TF, by the way, in Google Colab has its own way of, some things are very specific to Google Colab. So here, let's go back to the Colab window again, then say insert new code cell. We cut and paste the whole thing, and now you see cat, of course it won't recognize, so you'll get error, so don't do this. But basically what it will recognize is percentage sign, and what it will do is it will create a file of this TF digit detection model.py. So let's run this. It basically will just save. Right now it won't run, it will save this whole code in this kind of file, TF digit recognition model.py. So let's do that. Okay, let's do it. Oh, he didn't like end. Okay, so I knew that is the mistake. So we have to do percentage sign. So where is the percentage sign on my keyboard? So that's your percentage is, okay, there we go, I found it. So that is your percent. Now if you do, it will save this whole code as TF object detection. So let's see that, do that. Not found, very interesting. So let's ask Google or ChatGPT why it's not found. So Google Colab. So it's saying how to avoid using this unless needed. So you say, oh, write file, I see. It's not just percentage, you have to also say write file. So I'm sorry about that, guys. Okay, now you see, hopefully it will save this file. There we go. So okay, so you got your TF digit detection model.py. Now after that, how do we run this? So the way we run it is, I think I saved it in one of my other models. So what are the commands? So you see here we had vi tf nn, okay, cnn, convolutional. So okay, so these are the commands. Okay, so what happened to the things that I had saved? So Let's ask Google or ChatGPT to help us run this model. And so we'll go here and then say command to run the model in Google Colab. I think that one, all these we already have. Run your model. So okay, so let's say I saved the file using write file. Okay, so he's saying okay, so that's how you do it. So he's saying just do this. So let's try to run that now in Google Colab. I'm going to remove this. Let's go back to the Colab window. Say insert new code cell, and we say tf digit, not this one. We have to say tf digit detection model.py. So by the way, in Google Colab, you just have to these accumulation characters and these meta commands you have to know. They have this. So let's do that now. Let's run it. Okay, what it's saying, unable to register CNN factory, attempting to register factory. Okay, then it started running. So you say epoch 1 by 5, 1 of 5, and then second pass, the accuracy is already 96%, looking pretty good. And now the accuracy is basically fifth pass, the accuracy is already 98%. Okay, so predicted levels, true levels, wow, so this is great, but CV2 is not defined. Line 42 in more CV2 for image.m, it's in name CV2 is not defined. I'm surprised why it give this problem. I thought, let's ask ChatGPT again why is it giving this problem. So you say add this line at the top of a script. So import CV2. I'm surprised. I thought I already had it. So import. Okay, yeah. Actually, we don't have it. So let's do this. Import CV2 and let's run it again. Oh, run this command. Okay. Hopefully, we'll not have a problem this time. So this is pass 2. Okay. Now we have, okay, so accuracy, right? Okay, oh, actually now you see, even though it is 4, but it's actually predicting the digit 6. So that's where you see the problem is. So folks, you just saw how basically how the AI or the so-called this artificial intelligence, or in our case these models that we train, can give wrong results. So that's why you should be careful with self-driving cars and things like that, because you never know. I mean, if the model makes a mistake and it sees something wrong, it might do some lethal damage. So as you can see, in this case the digit that we fed it was 4. You can see in the code here 4 image. So now let's see how is this 4 image. Maybe we'll try to feed it a little bit better image so that it doesn't get confused. So let's do a insert code cell. Okay, and so let's run this code and see what we actually gave it, and it actually couldn't figure it out. It told us 6. So let's see that. So here you see this is 4, but the more predicted digit was 6. So this is coming from our predicted digit here, right? So let's you know what, let's run the code again, but what we would do is we would actually load a different image this time. So you say insert code cell, and we will actually do a little bit better image, 4 image. So let's run this code, browse, but this time we would go to 4, different 4, not that previous little bit confusing 4. So let's see that hopefully the model will be able to detect it this time. So here we are, person, screen, no sorry, 4, where is 4? I thought I had bunch of 4s. C, okay, D, C, D, E, F, 4, okay, there we go. So this time we had, last time we gave this, but this time we'll give this. This is very sharp 4, so open, okay, there we go. So we uploaded 4, and now we're going to change the code to have actually different image. So we take out this 4 image, you say 4.png. Now let's run this code. The code is already there, we don't have to cut and paste it again. Hopefully the predicted digit, see, predicted digit was wrong last time, 6, but this time we hope it will be 4. So let's save this file. So okay, overwriting, okay, good. Now let's run it again. So by the way, we are running MLP model, not the CNN model right now. CNN is basically not the CNN network that you are confused with, that what our president calls a fake news. And I guess it is probably fake news, CNN, BBC. But in any case, this is not that kind of media network. CNN means convolutional neural network. So it's saying CV2 is not defined. So let's fix that also. Import CV2. I thought we had already saved this, right? So how come it's saying import CV2, load the image, okay, no? Oh no, here. Oh, so now you see here, this time it ran and it's saying predicted digit is 4. And we'll run this code again, but this time we would do 4. Okay, let's do a insert Google code cell, but we know that it's not 4 image, the file name has changed, we have a more sharp 4. So let's try to see how come it was able to detect this time. So you see here, there you go. So this 4, by the way, this time it was able to predict correctly. So you just saw MLP model, TF digit recognition MLP model, multi-layer perceptron. Then there is another model similar which probably you can figure out yourself if you are curious type, or you could go to Google or one of these tools out there, Perplexity or something else, where they can give you a CNN model. This is also a deep learning model, and CNN stands for convolutional neural network. And sometimes, you know, I ask Google or say, why, how come it gave me the wrong result? It said, you know what, because your image may be fuzzy, but you can try a different model or you can change the image. So in this case we change the image, but it basically tells you, you get to see that how AI tools can be wrong and they can have wrong prediction. Basically AI is not something like something is so and so, something is so and so with such a probability. So probability is very important. So even it might say 100% probability or 96% probability. So right now you see when it predicted wrong, I think we still have that output, we don't have it, but basically I think the probability was still very high. So you have to be very careful, and that's why I always take these AI tools or the machines that use AI with a grain of salt. So I hope this session was useful for a change. And instead of this lead coding or hacker rank, we actually did something that is being widely very popular these days, which is model training and inferencing. So we did first inferencing on Raspberry Pi with a live feed of a camera using one of the classical ML models, Har Cascade, and then we did a training of a deep learning model for MN. You see this MNIST database of digits, and it even tells you number of GPUs available, and it was pretty fast because we were using a GPU model, and you should be able to know that how to change your runtime to use GPU instead of CPU, otherwise it will take a long time. So you see here when it says it ran, it says number of GPUs is, I think somewhere it said num GPUs available is 1. So that's why it was very quick. But I hope I leave you with all these today's interesting points, and I hope you'll build up on that, and probably also run more models. And you can use Google Colab. They give you free GPU, otherwise very hard to get a GPU cloud machine. So try some other models like YOLO or SSD, and I hope you will be able to make more progress on this model training and inferencing. And with those words, I leave you alone for the time being, and I'll see you in the next video. Bye bye.